All right, let us do some parallel problems. Okay, I'll write the description right below. However, it says I have a 120, a 60, and 40 ohm resistors that are connected in parallel across a battery that is 120 volts. Okay, so I wrote those down: 120, 60, 40, and then for my resistance, and then my voltage for the total is 120. So again, let's fill out this chart. Power we will always do last. So let's do this. I have to draw it first, and I said they're in parallel. Okay, so if they're in parallel, remember I can't do it in series, meaning I can't have only one loop. I need three different types of loops. So let me draw out my favorite way of doing this. So let me use a different marker. So there are multiple ways, but generally when I do something like this, I like to draw it like this. So there are three different resistors, and they're all in parallel. So make sure that you do it like this. You can have a different method. There are a few different ways to draw this, but this for me is my favorite. Okay, because you can see right here that they're all in parallel with each other. If you want, I can draw a different one real quick. Sometimes you might see it something like this. And then another one right here. That resistor could be anywhere along here. And then another one right here. So you can often see it like that. So one resistor, one resistor, one resistor. It's the same thing. I just turn it sideways and it looks like this. Anywho, so let's get this done. Okay, what a lot of you might do, because you're so anxious to get this done and you're so ready and you're like, man, I'm so smart, I got this, which you are. I actually appreciate, as for my students, more effort than relying on pure intelligence, because that can always falter. But the effort, you'll get there. So a lot of people, what I've seen a lot of people do is they just add this up. Oh yeah, I know how to do this, just like in series. 40 plus 60 plus 120, it's going to be 220, and they write 220 right here. Incorrect, children. Incorrect. Remember, when you have multiple pathways, okay, like this, before in series we only had one way. But because we have multiple pathways, the total resistance, if they're all in parallel, will go down tremendously. So whatever this value is, it's going to be even smaller than 40. Okay? Because you have multiple pathways, the resistance of the whole thing goes down, which means the current will come up. Remember that. Okay? So the resistance will go down and the current will go up, but the voltage will stay the same. Now remember, let's go over some things that we should know just from this case. So if I have this battery right here, no matter what, you're going to have to choose one of these three pathways, okay? I either could go this way, or this way, and then they'd all meet up here and reach there. But I can't do all three, so it's boom, boom, or boom. So what this means is that each resistor, the drop in every single resistor has to equal that coming out of the battery. So if this is 120 volts, then if I go this way, it's only going to reach one resistor. So that means the drop, potential drop across this resistor has to be 120. Same thing here, 120, 120. Okay, if I have a combination, that would be different. We would talk about that. The sum of their voltages would be equal to that, but well, that's another video. So again, because there's only one resistor through this pathway, the voltage drop through this has to be equal to that battery. So that is important. The other thing is that you can find the current here, because again, we have two knowns and one unknown. Figure that out. So this is another important fact. Remember, in series, the current is what stays the same, and the voltage is what sums up to the total. In parallel, it's the inverse of that. If everything's in parallel, the voltage stays the same, and then these currents should add up to this. So if you wanted to do that, then you could figure out this current 1, 2, and 3, and then add those up to get this current, and then figure out the total resistance. So you could do it that way, which, you know what, let's just do just in fact. So this V equals IR right? V equals IR 1, so 1I equals V1 divided by R1. So 120 divided by 120 is 1 amp. I2 is going to equal to V2 divided by R2, 2 amps. And then I3, I'm not even going to write it out, you should just see, is this divided by this, 3 amps. So 1, 2, 3, what do those add up? 6. Let's see if that's correct. Okay, now we'll put this off to the corner. Let us see what the resistance, the equivalent resistance is of this circuit. Since they're all in parallel, remember the equation for equivalent resistance in parallel is different than that of the resistance in series. We have to have this special formula. R1 plus 1 over R2 plus 1 over R3, and all that to the negative 1. So let's do that. So 1 over 120 plus 1 over 60 plus 1 over 40, all to the negative 1. You can do it in your calculator, or you should be able to do this with fractions. 1 over 120 plus 2 over 120 plus 3 over 120 to negative 1. That would be 6 over 120 to the negative 1, so 120 over 6, which just happens to be 20 ohms. Okay, so we know this to be true, so we know this is going to be 20 ohms. And look, forgetting about this, let's find the current of the equivalent resistance in this. So 120 divided by this actually does equal 6. So those are the ways that I can check my answer. Remember, parallel. If they're all in parallel, voltage is the same, current is what changes, and the current adds up to the total current from the circuit, which remember, this is something that is quite important. So the I total, or the I coming from here, is going to equal 6 amps, and then those 6 amps are going to be spread out. I guess it should be here. It's going to be spread out through here, I1, I2, and I3. So I is going to spread out into those three in after this junction, and then it will meet up again right here in this junction. It'll continue forth. Then it'll be I again back to its old self, 6 amps over here. So I1 would be 1 amp, 2 amps, and then 3 amps. It just coincides, that's funny. And then they would add up together again to equal 6 amps up here. So because so one thing you need to remember is that in this situation, this thing called junction rule is that it splits off. So what's coming out is equal to this, and what's coming in is equal to this coming out. So that's called the loop law, something to keep in the back of your head. This is actually the conservation of charge, because it makes sense, right? Current is related to charge, so the conservation of charge is in fact constant. Think of it as in cars. If I had multiple cars, they would be split up amongst these three, but the total number of cars, or the total number of charge, would still be equal. That's not going to change. The charge isn't going to jump away from the wire. It's going to stay there. Cool? Okay, just to make sure that our problem is 100% correct, let us find the power of this circuit. Okay, so remember, these are the equations. P equals IV, P equals I squared times R, or P equals V squared over R. Do you have to memorize all of them? No, memorize this, and also V equals IR, and the rest will fall into place. Okay, so I always like to do this first and then check with one of those later. So I'm not exactly going to write it out, or you know what, I'll do it for this first one. So P1 equals V1 I1. So if you do that, that would be 1 times 120. That would be 120 watts. So 120. And then we just do that again. V2 I2, this should be the same. This is twice that. So I would get 240. 3 times this should be 360. Okay. Now, to get there's multiple ways to check this. I could either do this times this, or I could just add all of these up, right? So if I do 6 times 120, what is that? Should be 720. Also, if you add all of these up, you should get 720 as well. But to also make sure if this is correct, make sure you use one of these ones also. Let's use this, I squared, so 1 times 1 times 120, 120, I squared times R, 4 times 60, 240, 9 times 40, 360. Also 36 times 20, this. So that way, you know, if you check it one way or another, you can find out whether you are correct 100% or not. And if it doesn't work, then there was an error somewhere and you're gonna have to go back to figure out where that was. Hopefully these problems are actually kind of fun for you. I kind of like them, they're not too bad. On to the next one. Let me do another problem. Okay, so this is another one that I gave you. So this is going to be a little more challenging. Okay, we have 2 known resistors in parallel and 1 unknown one. But something that we do know is the total current of the circuit, and we know the current of another one. So this is going to be a little tricky. All right, let's figure this out. Okay, my favorite way to draw them. I know, my resistors need work. Everything needs a lot of work, honestly. But, okay, so the voltage is unknown. The total current is known, but I know that my resistor here is going to be 12. Let me write that out. 12 ohms, 15 ohms, and then unknown. But I know my total current here, I, is 12 amps. Okay, and I know right here I2 is 4 amps. Okay, so that means if this is 4, 12 split up into these 3, this is 4, that means the sum of this current and the sum of this current has to equal 12. So the current here and the current here has to equal 8. It just has to be. Now this, just because there's 3 resistors doesn't mean that the current is going to be split up. Okay, now let's see what we can do. Okay, so remember Sudoku, right? Do you see anything where you have 2 boxes and 1 missing? Yeah, this one right here, right? So the voltage drop through this resistor is going to be equal to the resistance times the current. So that would be 60 volts. And remember, if everything is in parallel, that means that the voltage is drop through all of the resistors is identical, because this means that this is going to be 60 volts. You do not add the voltages up in parallel. They are identical. Okay, so because this will take either this route, that means the drop here, 60 volts. Because it takes this route, it would be 60 volts across that one resistor. Or because it would take this route, same thing. Because there's only one resistor, the drop has to be 60 volts no matter what. So then I can just copy and paste, and then copy and paste, and that helps me out tremendously. So it's these small rules that unlock the whole problem, and now I can figure everything else out. Okay, I can figure out the current here and the current here. Okay, so remember, I is equal to I1 plus I2 and plus I3. Let's write, and then V total equals V1, V2, V3. So I know my total is going to be 12 amps. My first one I don't know yet. I'll just leave that blank. Plus 4 amps plus some unknown. So let's figure this out, because again, 2 knowns, 1 unknown. All right, V equals IR. Let's write that out. V1 equals I1 times R1. So I1 will equal 60 volts divided by 12 ohms. If you do that, that is 5 amps. So 5 amps. Now we should be able to figure this out. If this is 5 amps and 4 amps, 5 plus 4 plus what number give me 12? what should that number be? Well, that number should be 3 amps. 3. Okay, now there's another way of doing this, okay, to figure out what these two unknowns could be. Okay, we know what this is, right? We know what this is. So, to figure out the resistance total equals V over I. Total over total. So that's going to equal 60 volts divided by 12 amps. That equals 5 ohms for the whole circuit. Now this part would be a little more challenging. I think the way that I did it is the easiest way to solve this, because if you want to find the equivalent resistance, you know that here, let me write this out this way. You know that the equivalent resistance is going to equal to 1 over R1 plus 1 over R2 plus 1 over R3 to the negative 1. And then you have this known, this known, this known, but you're trying to figure this out. That is definitely possible, but it might be a little more challenging algebraically. But I think, you know, most of you should be able to do this, but the easiest way would be this way. You can check this later. So if this is 3 amps and this is 60 amps, V equals IR, what times 3 gives me 60? Well, you should be able to figure that out. This would be 20. And then let's check our work to make sure that we're correct. So let's do the R equivalent. So it should be 5, right? We know that that should be 5. So let's just do R equivalent. Let's do 1 over 12 plus 1 over 15 plus 1 over 20 to the negative 1. Okay. I'm not going to do this in fractions, but if you do that, if you plug that into your calculator, it's actually not too bad. I think I could get to 120 and be able to do this. That would be, yeah, I'm not going to do that. 6, 8, 10, I think. It doesn't matter. If you do this, if you plug this into your calculator, R equivalent should be 5. Actually, it would be 8, 6, and 10, which is 24, and this bottom would be 120. So you'd flip that around. 120 divided by 24 would give me 5 ohms. So that would be correct. So that's correct. I know this problem was a little bit more challenging. Remember, this is the part that everyone forgets. Voltage in parallel stays the same. Current of each one adds up to the current of the total. Okay, and let's do power. Let's do power before I forget. Okay, so remember these 3 equations. It doesn't matter, just choose 2 to make sure you are correct. So P equals IV, my professor IV, shout out. Okay, and then P equals I squared times R, or P equals V squared over R. It doesn't matter, whichever one you choose. I'll just do this way and then you can check that way later. Okay, so let's do power equals 5 times 60. That should be 300. Okay, let's do this. 300, 4 times 240, and then 180. Okay, and then these should add up, even though, again, so even though these are in parallel, the power, the sum should be the same. Okay, so we do 12 times 60. What is that? Okay, 37 should be this. And let's see if you add all those up, that would be the answer. Cool. And then also you can plug these in. So I squared, so you do 25 times this would give me that. 16 times this would give me this, and 9 times this would give me that. And you could also do this squared over this. Doesn't matter, as long as the sum is correct here, you're golden. Hopefully this explains everything. I will do a combination video next, which is all of the worlds put together.